Welcome to today's program brought to you by the U.S. Botanic Garden. My name is Courtney Burris, the online education specialist with the Learning and Outreach team here at the Garden in Washington, D.C. For today's program, we will be providing transcription services. Please click the link shared in the chat to access that service. We're so happy to have you joining us online this summer for this special Plants and Music programming series where we explore the realm of plant music and we meet musicians, sound designers, and inventors and scientists who create and utilize innovative technologies to engage with plants in remarkable ways. Get ready for a truly unique and educational experience. Today's program, Can a Leaf Make Music, is an online demonstration presented by Dr. Paul V. Miller and Christopher Cox. This session will help to map the dynamic terrain of plant music, laying bare some of the science and technology behind it. Dr. Paul V. Miller has produced several live interactive sound installations with plants and published in academic journals about his work. He is an active musician, having held principal positions in the Washington Bach Consort and Opera Lafayette. Currently, Paul serves as an associate professor of music at Duquesne University in Pittsburgh, and previously he worked as a Mellon postdoctoral fellow at Cornell. He studied at Vassar College, the Eastman School of Music, and for 6 summers in Karlheinz Stockhausen in Germany. A lifetime lover of the outdoors, Paul grew up hiking the Shawangunk Mountains near New Paltz, New York. I almost got through it. Christopher Cox is a graduate of the Duquesne University Mary Pappard School of Music in trumpet performance and currently works as an organ builder with the Lully Organ Company in Pittsburgh. He performs orchestrally as well as on Baroque trumpet and is a music library intern with the Pittsburgh Symphony Orchestra. In addition to his music, Christopher has a deep interest in electronics and engineering. Without further ado, welcome Dr. Paul Miller and Chris Cox.
Well, thank you so much, Courtney, for having us. Thank you for introducing yourselves. We're seeing all the names roll by in the chat window. It's great to see you all from Minnesota, Virginia, DC, New York, New Jersey, and other places. So with a presentation like this, a lot of things can go wrong because we want to show you some technology and some biology and some other things. Also, there's quite a wide range of disciplines involved. Plant music is a very kind of radically interdisciplinary thing that has associations from biology, electrical engineering, computer science, and music, last but not least. So we made some videos. We made 2 videos that we're going to play, which will do most of the talk. The videos will do the job, and that way they'll go smoothly. So we'll just start the first one here. And both videos are about 17 minutes long, and there'll be time for questions after each video. So after the first video, we'll have time for some questions, and then after the second video, we'll have time for some questions as well. So here we go. Enjoy our first video. Here we go. To understand how most people make plant music, I have a couple things here to show you. This is a voltmeter, which also measures electrical resistance. I have a very inexpensive electronic component. This is a resistor, and I have a J-plant with some TENS cables attached. So TENS cables were invented in the 1980s. They have a conductive metallic film inside that's bendable, and adhesive gel that's also electrically conductive that can stick to things. They were originally developed to stick to skin, so that you could send electric charge through your body to stimulate muscles. And you can get these at drugstores nowadays. They're not very expensive. So let's take the probes from my voltmeter and measure the resistance on this electronic component. It should be about 220 ohms, and I think it comes a bit under. And there you go. That's a typical resistor. But if I put my probes on my finger, then I'm going to notice that I am also electrically resistive. So there is some resistance in my skin between these 2 probes. And I know that because right now, when it says auto, it's not measuring it's measuring no or negligible resistance. Whatever electrical resistance there is in the air is negligible. But if I touch the probes together, it will beep because I'm getting a short circuit. So I have quite a high amount of electrical resistance, I think on the order of a few mega ohms, but there you go. So now if I go to the plant, well, the TENS probes are sending their signal out through this jack here, and you notice that there is a shaft and a tip, and so one probe is going through the shaft and the other through the tip. So if I touch my probes here, I can measure how much electrical resistance there is through the plant, and this is harder than it looks, so bear with me here. I gotta get these two probes just in the right place and then hold them. Yeah, okay, there we go, that's it. So that's, let me just get a good connection there. Okay, great. So that's how much resistance there is through the plant. Now, this doesn't work all the time, but a lot of times people like to touch their plants. And when I do that, I'm going to be sending my own electrical charge through the plant and affecting the amount of resistance. So I am also a capacitor. I hold electric charge in my body. And so when I touch the plant, I'm going to be passing that through it and probably affecting the amount of resistance in the measurement. So let's get that back to where it was, all right? And let's go ahead and see what effect I am having. Okay, now that we've seen some of the hardware side of plant music, let's take a look at the software side of it all. So I have here open two applications. One of them is Max MSP. So this is software that's been around since the 1980s. It's a patching environment, and many creative people use this software to make sound, music, and video art. And I've made a patch here that I'm going to show you in just a minute. Over here is Ableton Live. So this is a DAW. This is called a digital audio workstation, and producers use this to record music and edit it and master it and make albums. DJs use Ableton to put their sets up and then play a show, and it's a popular way of making sound and music. So over here, let's take a look at Max. So here is a little excerpt from a recent essay published in New Phytologist, and this is the action potential voltage in the Venus flytrap. So this is a really interesting curve that's been known since the 1860s when Charles Darwin first investigated the Venus flytrap. And the way that the flytrap works is that it sends a trigger that you're seeing there, a voltage. And when the plant gets that trigger, it closes up on the bug. So it actually produces this voltage. Unlike what we saw a minute ago, where I was just kind of passively measuring the electrical resistance in the plant, this is an active kind of thing that a plant actually produces itself. And you can see that this signal takes about a little over 2 seconds, and it's not very much electricity, but it's some. And you can see that there's a high point to trigger the closing of the trap. Well, in Max, I can kind of model that as best I can and record it into a memory buffer. So let's do that. Let's save this and let's record my modeling of the Venus flytrap voltage. And then I can use that to play sound. So here's a fake keyboard. So you can see the shape of the Venus flytrap voltage that's being mapped onto a key here. And so high frequency is a short wavelength, and so the software is compressing the wave. And then a low frequency is a long wave, so it's expanding the Venus flytrap voltage that I've modeled. And so that's kind of fun, but you could take a MIDI file of a familiar piece to many people and use that to play the Venus flytrap signal. So here we go. So that's kind of fun, and it's interesting, and it is actually something that I've taken from the plant world, from the vegetative domain, and turned it into something musical. But you know, you could do that with just about anything. I mean, you can bang on a can and record the waveform and extract a small amount and cycle it through, and you can make Bach sound from a noise that you just banged on a can with. So most commercial plant music devices work in a somewhat more sophisticated way than this. And so that's what this part of the patch is all about. So the way it works is, let's imagine down here in this box here, let's imagine that this is a graph of electrical resistance that's been measured from a plant passively, the way I showed you in the last video. So along the x-axis here is time, and along the y-axis is some kind of measurement of electrical resistance through time, right? And I'm just drawing these values here for the sake of the demonstration here. And this particular curve is quite stable. It doesn't vary that much. So the way that most devices work then is that they'll take a buffer of 10 or 8 or 10 of these samples. And so this is one such buffer. And I'm just using arbitrary values here. 43, 42 just represent some arbitrary imaginary measurement of electrical resistance in the plant. And then what the algorithm will do is take the standard deviation of those 8 or 10 values. So if that standard deviation is above a certain user-defined threshold, the device will output a note. And in fact, on most devices, including the one I'm going to show you in a minute, there's even a knob to set that threshold. And you might be able to see the little black dial here, which is the knob that sets the threshold on my device. Here in my patch, I have a rotary knob that sets that threshold. So if the standard deviation of these 10 or 8 values exceeds that threshold, the algorithm will output a note. So then you ask yourself, what note will it output? Well, it will output a note that's scaled between some range of values, a low-pitched sound and a high-pitched sound. So let's just take a look down here. So first, we measure the electrical resistance from the plant, and then 10 or 8 values are read into a buffer. We compute the standard deviation, which is the amount of variation in that data in the buffer. And if the standard deviation is above a user-defined threshold, we'll output a note. Then we need to scale that note to a certain range so that the range of pitch is within human hearing, low and high frequency. Lastly, a lot of times when all of that is said and done, the notes that come out can sound somewhat chaotic and random and not very musical to our enculturated musical hearing. And so the last step, one of the last steps in this whole long process is to quantize that note, or to snap it to a grid of pitches that make musical sense to our culturally defined norms of musical sound. So over here, what I've done is I have a high range of notes, and I have a set of bass notes, so melodic notes and harmonic notes here. And it's going to be acting upon the same data set, but it's going to be quantizing it to a different range of notes. And just to make it easy to understand, you can watch this little box, this yellow box, move through the data set. And that is the buffer of 10 values that are being sampled at any one time, on which the standard deviation is being calculated. Now, if I run this, you're going to notice that not much comes out. And that's because there's not much variation in the signal here, the pretend signal. So let's run it and see if we get any notes. We'll set our thresholds very high so that almost guaranteed to have something come out. Nothing. You can see that the standard deviation is very low. It's below 1 here. So nothing is coming out. That's what I expected. Now, if I use a different preset, let's say this curve. Now, this is imaginary kind of measurement of electrical resistance over time in the plant. Now, there's a lot of variation here. So let's see what happens if I run this through my system. So there's a lot of variation in the data, and so it triggers notes very frequently. And what we saw in the demo before was that when I touch the plant, there's a lot of variation in the electrical resistance. So most systems that you'll buy or you'll see online are configured such that when you touch the plant, a lot of sounds come out, which invites us to kind of interact with plants. But it's also somewhat artificial because it's not actually the plant itself that's generating that electrical resistance. It's us. So let's try one other preset. So here, is kind of like a sort of calm moment. I'm using somewhat anthropomorphic language here. We imagine the plant is not outputting much variation in electrical resistance. And then let's say I touch it, and then I don't touch it, and then I touch it again, and I get a lot of zigzaggies. So what happens now? Exactly. So you can see this is the principle by which a lot of commercial devices work. And you can see how it's very inviting to interact with your house plant. Now, okay, so the sounds that I've outputted so far are this kind of generic piano sound, which is perfectly fine. But as a musician, I find it, usable in a certain kind of way, but it's not the most musical sound I can imagine. So I can route my MIDI values, my notes, to Ableton. And here I can set up a lot of instruments. So I have kind of like a little ensemble here with some beats, some bass notes, and some middles and some highs. So you can see that I have MIDI from max 1. So my bass notes here are max 1. They're being sent these bass notes are being set to my bass and my middle frequency sounds. And then my melodic notes are going to go to the inputs called max 2 right here. So these will be more my mid and high notes. So let's bring these instruments in one at a time. And why don't I take this more active curve here just to be sure. There we go. So let's turn these on. Let's get it playing. And then one by one, I'm going to turn these instruments on so you can hear them. So I have my beats. And there we go. Okay, so what I have here is a do-it-yourself version of the original Plant Music box, which is the Plant Wave. So the Plant Wave came out in 2012, and it was very, very successful. And so one of the makers of the Plant Wave made this do-it-yourself kit, which I soldered together, and it has a 3D printed box and a lot of colorful LEDs that light up. And this is just hooked up into the Jade plant I showed you before. And the jack goes right into the board, and a USB cable comes out into my computer and into Ableton. So I have this track set up right here, this green track, to show you what this sounds like. So I have a marimba sound on it. There's my vibes right there. And I have a scale, a quantization, and an arpeggiator, but they're turned off right now. So let's see what the MIDI notes are coming out, what they look like. And let's bring up the volume. So this device doesn't produce a great variety of notes. And you can see that this isn't the most musical thing from most people's perspective. So if we engage the quantizer and the arpeggiator, we can get something a little bit more interesting. So you can see that with a little bit more work, this could turn into something really nice. But there's a lot of mediation and a lot of intervention that goes on behind the scenes. Usually when you buy these devices, all of this stuff is wired in, so you don't have to make any of the decisions at all, aside from maybe selecting some type or genre of sound that you wanted to make. But when you really get down to what's going on, you can see that a lot of this is done by software and not so much by the plant itself. And this leads us to our next topic, which I'll speak about in the second video. I think a lot of the result we hear is very highly mediated by people. So you're really listening to a person. You know, we're used to this. You buy an album or you download an album, you're often downloading a person's work. And so the technical side of this can sometimes obscure the fact that it's a lot of manipulation of information going on. And it's a very little of the plant is actually coming through. And even what is coming through is somewhat questionable sometimes because it's a passive measurement of resistance. Yeah. So I think to keep in mind that we're listening to a person's artwork for the most part. And what the plant adds is kind of problematic, a questionable thing, which we'll talk about a little more in the second video, but I think it's a great question, Courtney. Thank you.
Yeah. Oh, no problem. I think it reminds me of, and we do have some questions in the chat. I guess going up to a producer that, you know, helps a musician, right? And saying, hey, how can I do this at home? And the producer's like, well, wait a minute. It's a couple of other things that go on here, right? It's my ear as a producer, the co-collaboration with the artist, right? And in this case, it sounds like the artist is the plant. So here's a question.
I would be quite clear actually to remind everyone that the artist is the person who is sort of manipulating and modifying the data that's coming out from these boxes that you can buy. There's another way to do this. A lot of these boxes will do a lot of the work for you. So you just have to press a button and boom, you get sound in whatever genre you like. And it's kind of an automatic kind of thing.
Yeah. But what you are talking about, thank you for making that distinction, that the artist is the producer. Or
the algorithm. The algorithm that is, when I turned on the quantization and the arpeggiator, like all that stuff can be coded into a plant music box, and you just press a button or select a setting from a menu, and out it comes. And that obscures a lot of what's going on.
That is very cool. Wow. Okay, so we do have a question here from the chat. Do different plants make different patterns in frequencies?
Do you want to answer?
Yes, they have different sort of electrical patterns that they'll make. So throughout the day, different processes that the plant might be going through. So we had found that some plants could be much more active than others. But we're not necessarily looking at frequencies that the plants give out. It's just strictly the electrical voltage that we're using to control with.
Plants have a daily cycle of respiration, and they pump water into their leaves. That's one of the great things of terrestrial plants. They pump water up into their organs, and then they pump it out. And they do this on a daily cycle. So if you are patient enough to listen to plant music for 24 hours straight, you might hear some really significant distinctions. Also, software algorithms will play all kinds of tricks to make it appear as though changes are happening more rapidly than they might actually be happening. So part of what we see our work as doing is, on the one hand, we love the fact that we're involving the vegetal world in this, and we love that this is a way to connect to that. But we also want to tell people what is actually going on. It's not some sort of magic. It's not some sort of inaccessible thing. There is a tangible software and hardware decisions that people have made in order often to sell you a product. Okay. So that's a little bit more what we'll speak about in the second video. Is there one more? Maybe we have time for one more question before we start the second video. And there'll be more time after the second video to ask questions too.
Okay, and we'll keep in with the technical. And this is definitely a musical person's question we have here. Can you dedicate the pitches for a pentatonic scale?
Yes, you can.
Okay.
You can quantize it, and within the range of data points that it'll look for, or the range of voltages, you can have it so it will be equally divided among the pitches of a pentatonic scale, any scale, anything that you'd want.
Yeah. And this can happen with multiple plants, right?
Yes, it can.
Yeah.
Yeah, multiple plants, and I don't think we've done with multiple leaves on the same plant, but just using separate plants, just so things don't get confused, or there wouldn't be any sort of grounding loop between this, having it on the same plant.
Gotcha.
Now, it's important to realize that quantizing plant resistance, measurements of plant electrical resistance is only one way to make plant music. I mean, you can use the data for any purpose you want. You can use it to sequence samples. So one thing we did was we took the bird song, Nightingale song, and we just quantized it. We just split it up into 100 samples. And then we sequenced those samples. We played them out of order, and the plant the plant voltage, the resistance in the plant leaf was picking which sample to play. So making music in the kind of enculturated Western idea of the note is only one way of doing it. Now we go out to buy a plant music box, and it typically makes music we're familiar with, but there's a lot more that you can do with it. And sequencing samples is just one very creative way. You'll see at the end of our second video what can be done with this to get beyond the note. So shall we? There's a lot of really interesting questions I'm seeing that I'd like to talk about in a little bit, but let's play the second video, and we'll get to some of those later. And of course, we'll also be happy to take a list of all the questions and respond to them if you want to. I might post answers to these questions on my website. So nobody has to send me their email address. I'll just go through and answer them and post all the answers on my website, and then you can just read it tomorrow and to your heart's content. But let's do the second video now, and then again, there'll be time afterwards to answer some more questions.
Okay, perfect.
Here we go, video 2. In this video, I want to ask the question, can a leaf really make music? And also I want to ask some questions about the ethics of collaborating with plants. Now, if you were going to collaborate with a human musician, there are a couple things you might want to know. You might want to know where that person came from, or what music might mean to them, or what some of their experiences might be, what they're trying to tell you through the music. Now, we can't ask the plant all those questions, but we can approach the plant in a similar kind of way. So let's get right into it then. Our way of thinking about plants has changed a lot in the 50 years since The Secret Life of Plants was published in 1973. This book was widely ridiculed in the scientific literature because it made a whole litany of unscientific claims about what plants could do. Some of them were quite fantastic. Some writers like Michael Pollan think that this book single-handedly set research on plant cognition back a couple of decades. More recently, Daniel Chamovitz wrote a book, What a Plant Knows, which is a terrific and very readable book that deals with plant perception and plant senses, sort of what the world looks like to a plant. It's a terrific book. I highly recommend it. Just about a year later, Michael Marder came out with his book, Plant Thinking, A Philosophy of Vegetal Life. This is a very sophisticated book of philosophy. In some places it's difficult to read, but in many places it's thrilling. It's a great book. It very deeply resonated with me and changed a lot of my ideas. Highly recommended. The most recent book was Zoe Schlanger's The Light Eaters, which just got a very big piece on NPR. And Schlanger does a great job of condensing scientific research from the last 20 or 30 years in a very readable piece of literature. You know, plants can recognize each other. Some of them can change the shape of their bodies to blend into surroundings. To a certain extent, some plants can exhibit behavior, and they communicate in many sophisticated ways. So Schlanger's book is a very good summary of a lot of the most recent research on this. So now, as we saw in the last video, there are devices that we can use to pick up electrical signals from plants to make music. And you saw this one right here, which is the one I built. This is the original PlantWave from 2012, comes in a cardboard box. Its successor here is updated a couple of years later. And there are various other devices. This one costs about $800 down here, and it comes in a nice bamboo case. This is one that Christopher and I built ourselves for about $15, and it does a lot of cool stuff for a lot less money. But what's interesting about all of these devices is that they tune into electrical signals. Now, plants have very sophisticated chemical signaling mechanisms. So why aren't we sniffing the air and making music out of plants' chemical signals? Because they do a lot in that domain. Well, a couple of reasons, I think. First, it's much cheaper and much easier to build devices that sense electrical signals rather than chemical ones. But also, I think there's a certain bias, because what makes our brains tick is the firing of neurons. Neurons fire electrical signals. We have synapses and we have neurotransmitters, some things that plants don't have, and yet plants still manage to send electrical signals through their tissues. So already in all of the devices we use to make plant music, there is a kind of human bias towards reading the medium that we're looking at as the electrical medium. So that's something to keep in mind as we go through the next few slides. So here's some electrical signals that are really interesting that happen in plants, which our devices to make plant music are not really set up to measure. Here's some research from the University of Wisconsin in Madison. Here's a caterpillar devouring a leaf. And there's some fluorescent dyes that show how calcium ions, which are electrically charged, how they travel through plant tissue. It would be really interesting if our plant music could respond to this, and it only does so very tangentially, if at all, because it's mostly sensitive to resistance. Here's another video of an unwounded leaf. Some other part of the plant has been attacked. And so let's see what happens electrically in this leaf. Well, a lot. So this would be something that would be really interesting that we could use. But in order to pick up these signals and make music out of them, we would have to use tiny electrodes that would go into the plant itself. And those are really expensive and they're hard to set up. Maybe in the future we can do that, but for now we're limited to these TENS cables, which are a fairly crude mechanism. It's also really interesting to me to look at the source code that runs on a lot of the plant music boxes I showed you a few slides ago. This is the source code that runs on the PlantWave and my own do-it-yourself box, and it's inspired many other software engineers to make similar code on their own devices. And this code is available for free on GitHub. It's in the public domain. And here you can see the scale quantization of electrical signals coming out of plants. And you can see that it maps it to Western scales, major, minor, chromatic. And there's even this one Indian, which I don't understand what that is. As a musician, this is almost kind of offensive to me because in India, there's 2,000 ragas in Hindustani India, and there's another 2,000 of them cataloged in Carnatic India. And so what is this? I don't know what this is. So you can see that there's a lot of mediation and there's a lot of questions that could be asked about just what's the process behind making music with plants and how does the biological world get through all of this stuff we put in the way of it. Okay, so what's at stake here? Well, does plant music do physical harm to plants? Well, no, not really. Even if a biosensor, one of those TENS cables, tears off a leaf, as I have done many times myself by accident, well, plant bodies are generally reproducible. The plant's an assemblage of parts, not a unified whole. And plants don't usually strive to protect their leaves as we would protect an arm, a leg, an eye, or even a child. Does plant music physically harm or do violence to people? Well, I guess you could play it really, really loud. You could annoy your neighbor, but no, not really. But does plant music do violence to our relationship with the vegetative domain? Well, it could. And here's why I think so. Okay, so I'm going to problematize plant music and get a little more into some of the ethical questions. So, people can attribute qualities and powers to plants that appear only thanks to many opaque layers of technical mediation, as we've seen. And this process can look like, to some, as a kind of magic or even sorcery. And because plant music flows so readily, so continually, so easily through our electronics, it can sometimes be tempting to understand plants as somehow musically gagged. The thinking goes, modern technology can free plants to sing, and without us and without the technology, they're mute. And in a capitalist economy, purveyors of plant music can sometimes employ plants as a strategy to upvalue their brand. And in this view, plants provide extra value that differentiates one artist's music from another's. And the philosopher Kierkegaard, we could paraphrase him by saying, how something is said and who says it is as important as what is being said. So the fact that the plant is making the music is as important as what the music is like itself. There is a certain sense of bleed through sometimes, and the presentation or appearance of a plant hooked up to a computer can accrete plant-like associations onto the music. And at best, plant music puts the human and vegetative domains in a commensalist relationship, in which the plant receives little or no benefit or harm, but the person receives considerable benefit. And I would say that at worst, plant music aligns plants and people in a parasitic relationship, as capitalist models objectify plants as nothing more than a live stream of variable data or a continuous stochastic process, which occludes a deeper and more honest encounter with the phytosphere. Here we come to our last slide, where we ask, what might an ethical musical collaboration with plants sound like? And in my own practice, I want to abandon or at least critique enculturated norms of music or organized sound from the human world. Ideas such as tonality, the concept of the note, schematic form like ABA or AAB form, things like the anthrotemporality. You know, we live on such a compressed time scale of seconds, minutes, hours, whereas plants live more on a time scale of the cycle of the day or the season or the year. Plant temporality is very different from ours, and I'm very interested in that, and maybe our sound or our music can reflect that. Also, human concepts of meter and timbre. In my own practice, I want to give up something of my own sense of music, but this is a real challenge. So what's the music or sound proper to plants? So plants don't really need music to survive or to impress other plants or to find a mate. And so what is the sense of music or sound proper to plants? Well, I don't know. Maybe we'll find out one of these days. Maybe we'll never find out. But it's an interesting question to ponder. I want to engage personally with the vegetal world through sounds in the natural environment. So what kinds of sounds might happen around plants? Well, sounds of water, wind, earth, rocks falling, things of that nature, fire, insects. These are the sounds that plants that are around plants. And I like to think that those sounds might be more proper to the world of plants. And I, above all, don't want to conceal the extensive mediation that converts plant biosignals into sound or into music. This is the whole purpose of this talk. And now that we're near the end, we'll watch just a little bit of an installation that Christopher Cox and I set up a few years ago here at Duquesne University. In this installation, we had 4 plants set up, and each of them, their electrical resistance was influencing the way in which samples of water, wind, earth, and fire sounds were being played back. And we had an iPad interface, and on the iPad interface were human sounds, sounds from the human world, such as a locomotive, or people selling fish on the streets of London, or applause in a theater, or a church bell. And when you triggered these human sounds from the human world, it distorted and ripped apart the sounds of the natural world. It distorted them, it punctured them in various ways. It was something of an advocacy project, but I think there was also some aesthetic outcome. So here we go. This took place in the library of Duquesne University in the reading room. Over the course of about 2 weeks, we had it running every day. Well, we see a very dramatic part of the installation. It was actually quite calming to a lot of people. A lot of the students went in there to read or to do homework when people were not triggering the human samples, and they found it kind of relaxing. But I guess we sort of have here one of the more dramatic moments. So I hope you enjoyed our presentation, and I want to close by thanking the United States Botanical Gardens for having us do this. It was a real treat. Thanks for bringing us here.
And so we have a question asking, why does it, I'm assuming the sound, why does it sound so new agey? What's that about?
That's because the designers, the sound designers wanted that. You know, okay, so the first video we saw the patcher window of Max, that software Max MSP. And one of the people who was involved with writing that software in the 1980s and 90s was a guy named David Ciccarelli. And David Ciccarelli thought of Max as communication with meaningless numbers. So what does it mean? Communication with meaningless numbers. All that Max operates on and all that plant music really operates on are meaningless numbers. They're measurements of electrical resistance in a plant leaf, okay? And what those numbers mean is up to you. They're up to the sound designer, they're up to the software programmer, they can be up to the hardware designer too. How do you want to measure that electrical resistance using hardware? Those are, what electrical components are best at measuring resistance. Those are choices that an electrical engineer can make, part of the process. Software designer, instrumentation, all of those are human decisions. So the plant is only giving us a stream of meaningless numbers. You want to make it sound like new age music, fine. You want to make it sound like classical music, you can get pretty close. You want to make it sound like a sound installation with sounds of earth, air, water, and fire samples being shifted around and panned and pitch shifted. You can do that too. So there is no one type of plant music. It's up to the human mediation.
Yeah. Yeah, and we'll see that in this series this summer. We have biotherapeutic sound baths coming with that same idea. They've made the sounds in a way that's pleasing to them and their audience, and they're using the plant to kind of be that. What would you call that? Is the plant the foundation or the source of the sounds?
Um, I guess the sound wouldn't be happening without the plant because there would be
Okay,
no input or control voltage.
right.
So I was sort of thinking earlier, it's really similar. There's a very basic little electronics kit. There's a light sensor and with a buzzer attached to it. And you put your hand over it and the pitch changes. And you take your hand away and the pitch goes up and you cover it
Hmm.
and make it darker and the pitch
Hmm.
goes down. That's just the same thing, sort of a control voltage.
Gotcha. Gotcha. Yeah, I this idea of making music with plants, like what has that once you got the idea, right? Like let's think back of years ago when you finally got this idea, like, well, you can really do this. How did that or did that change your relationships with plants, like with the natural world?
Well, I think that what it did for me personally was I wanted to kind of sift through some of the mystery of it all. And I
Mm-hmm.
wanted to figure out what was actually going on and how it worked, which is
Mm-hmm.
why I made a lot of measurements of electrical resistance myself. And then I built well, actually, Christopher built a box to output meaningless numbers from
Yeah,
plant resistance. He actually did an amazing job, this guy.
yeah, that's
And then
amazing.
we just built it. We built it. We did it by actually going through all the steps. And then
Mm-hmm.
we looked at a lot of philosophy and a lot of kind of ideas of like what is actually happening in terms of like the human involvement and the human engagement.
Yeah.
This is, what plant music is mostly, I think, about us. I
Okay.
think it's mostly about us. I think it's less. I think in some case now, one person put. May I, Courtney? Can I actually address one or two of the questions directly? So somebody
Absolutely.
asked. Somebody asked a few questions ago. Recommendations. Jennifer Reifsteck. Jennifer, you asked a great question. Are there any recording artists or albums you'd recommend that feature plant music? Well, there are two that I really like. One of them is a guy by a guy named, and I'm going to type his name in, Augustine Ludar. So Augustine Ludar is from Belfast, Northern Ireland, but he lived for about 12 years in the Amazon rainforest. And Augustine did an advocacy project for conserving the rainforest based on the signals that he measured going through the electrical signals going underground through the fungal networks underground. And there was a famous article in Nature about 15 years ago about this. Plants send signals underground through fungal networks to each other in the rainforest. And Augustine was able to measure this by drilling holes into trees and attaching sensors into the trees themselves. He didn't damage the trees very much. And he was able to actually pan sounds around the rainforest because he had speakers in the trees, loudspeakers in the trees. And he was able to pan sounds in the shape that he seemed to detect these signals going underground. But he also used the sounds of insects and birds and other sounds native to the rainforest. It was not a musical project so much as a sound project. And I really love what Augustine has done. I've spoken with him many times. He's a terrific guy. And he has really lived a life. He lived in the rainforest for years and years. And I really like what he's doing. Unfortunately, it's hard to find his music, although there are videos on YouTube. And
Mhm.
another guy who I really like is a Japanese artist named Mamoru Fujieda. Um, so Mamoru, and I just put his name in the chat box. So Mamoru Fujieda is a really great composer in Japan, and he used sensors kind of like what we do, but a little different. And he got into this in the 1990s, so he's like the grandfather of it all in some ways. And he like is perfectly upfront about the fact that he collects data, the electrical resistance measurements, and he just selects measurements that he likes. And he makes music from that. Like, he's not trying to conceal what's going on. He just says up front in the prefaces to his piano music and to his music for Japanese instruments like the koto and the shakuhachi. He just says, I just find some values that I like and I make them into music and I compose with them. So I really like Fujieda's art a lot, and it's very different from Ludar. So there's a huge spectrum out there. It's not just new age. It's not just some sort of genre. It's whatever we want it to be, and that's why I think plant music tells us a lot about ourselves in a lot of ways. I see we only have 3 minutes left, but there was another question that I really liked, and that was, Mickey Hamill. You asked, do different plants make different patterns of... Oh, actually, yes, we answered that. The answer is yes. The answer is yes.
He also asked about the types and volume of sound affecting the plants.
Oh, right. So this is Delia Love. Yeah, Delia Love. Delia, thank you for your question. Hello from Florida. Have there been any studies done on large scale regarding plant growth with music? So there is a study I have read in a peer-reviewed journal about the growth rate of certain plants, how it's increased when sounds like drone sounds of certain frequencies are played back. Somewhere around 200, 300 hertz. That would be around middle C if you're a musician. The theory is that it's possible that the vibrations move dust off the leaf, exposing the leaf to more sunlight, making it easier for the plant to grow. But to be honest, biologists aren't quite sure the effect of sound on plant growth, but there seems to be at least a small connection there. I don't want to overstate anything, but it does seem to be like an area of research that has a somewhat promising future. There have been a lot of people trying to play music. Heavy metal music makes plants die, and classical music makes plants grow. And all of this, you got to read this with a lot of skepticism, because what may be just going on is some sort of effect that has to do with just the vibrations getting the plant into more contact with nutrients or light or something like that.
Thank you. Thank you all so much. We are, coming to a close today, but thank you all so much for attending today. And thank you, Dr. Miller and Chris, for sharing how your expertise with music has brought you so passionately into the world of plants and teaching us so much about plant music. Please visit his website at theoryofpaul.net. /plants. We can go ahead and drop that in the chat for you. Happy to. And to learn about, I know how cool, right? To learn about future online program offerings, please visit usbg.gov/programs. We have more plants and music series coming up. We have biotherapeutic sound bath with plants with the local artist Imka. You get to see some of those things in action that Dr. Miller and Chris taught us about today. We also have connecting with plant music. We have Joe Patitucci, the speaker and the inventor of Plant Wave, coming on as well. So we get to ask questions and we get to run the gambit of this idea of interacting with plants. So we are so excited to have you all join us. Thank you. And we will see you soon. Thanks again. Y'all have a wonderful, wonderful afternoon.
Thank you.
Thanks.
Thank you.